Hello, chemistry. If things have gone as they should, you've already watched a video that will show you how to convert liters of a gas into moles of a gas, and vice versa. The conversion factor is 1 mole of any gas is 22.4 liters. The problem that is on the screen right now is a standard problem from your homework. As a matter of fact, this is one of the problems from your homework. This is problem number 1. So, what I first want to do is review some of the mole conversions that we know how to do at this point in time, including the new one. So I'm just going to make the whole screen go away here. The first conversion factor I have is right here. This is the first thing we learned in this unit, which helps us understand how moles of one type of substance would be related to moles of another type of substance. So 2 moles of sodium is equal to 2 moles of water. 2 moles of sodium is equal to 2 moles of sodium hydroxide. 2 moles of sodium would be equal to 1 mole of hydrogen gas. And I could do that with any of the conversion factors in this balanced formula. So balancing a formula now has a new meaning to us. Down here in this corner, I have the conversion factor that we just watched a video on. The purpose of this assignment is to learn how to use that conversion factor. And then I have a good old one over here, that 1 mole of any element, doesn't matter what it is. It could be 1 mole of a compound, is the molar mass from the periodic table. If it's a compound, you'd have to add up the different individual masses. In this case, I do have the conversion factor that I need specifically by looking at a periodic table. It's right here. And this is 1 mole. This is the conversion factor that I will need for this problem. So let's break the problem down. To find the mass of sodium required to produce 5.68 liters of hydrogen gas at STP. So the first thing you do in any conversion problem is write down what you know. So I have 5.6 liters of hydrogen gas. So now when I'm looking at the conversion factors that I can use, I have this one over here. This one does not have anything about liters in it. I have the conversion factor that would use a balanced equation, which is about going from moles of one thing, whatever it is, to moles of something else. Well, that's moles to moles. I don't have that unit. I have liters. So that's, I have to use this one down here. Since liters of hydrogen gas is on the top, I need to use liters of hydrogen gas on the bottom. And 1 mole of any gas is 22.4 liters. That's always true as long as the gas is at STP. 1 mole of any gas is equal to 22.4 liters. So now I'm to moles of hydrogen. And if I'm to moles of hydrogen, I could use, well, probably not this one, because this one says something about elements. But up here, in the balanced equation, that's how you convert moles of one thing to moles of something else. So I know I'm going to do a mole to mole conversion. And specifically, according to the way this problem is laid out, I'm trying to go from moles of hydrogen to moles of sodium. And I know that because, first of all, whatever the unit is here has to be down here. And then you look at, where am I trying to go in this problem? I'm trying to go to sodium. This concept is not new. We've done this now on several assignments. So this is the mole to mole conversion. In order to go from 1 moles of one thing to moles of something else, you need the balanced equation. So when I am looking at my balanced equation, moles of sodium are right here. Moles of hydrogen are right here. So I need 2 moles of sodium for every 1 mole of hydrogen. And finally, now that I have moles of sodium, I can use the conversion factor to go from element to mass. Take out your handy dandy calculator, multiply all the numbers on the top, divide by all the numbers on the bottom, and when you do that, you will get your answer. The answer should be rounded to the appropriate number of significant digits, which is 1, 2, 3 significant digits. So in order for me to make 5.68 liters of hydrogen gas, this is how much sodium I would have to measure at the beginning of the lab. If I were to go to the answers only for this particular assignment and look at the answer to number 1. The answer to number 1 is indeed 11.7 grams of sodium. And then I also have here the answers to the other problems. So as you are working on those problems, make sure you are checking your answers to get it right. If you are not getting it right, you should be asking a friend for help at this time.